So section 5.2 is called the definite integral. So we talked about in the first introductory section of chapter 5, how do I find the area of a region that lies under some curve. So that was all about finding the area by creating rectangles. That's how you do it. We can find any net area under a curve to the x-axis by creating rectangles. Now this section, all I'm going to do is say what we did in 5.1, okay, this limit statement, the limit of this sum, of the Riemann sum, is actually just an integral. So what this symbol means integral. What is an integral? A definite integral, meaning if I have an integral from a to b where a and b are going to be numbers, of some function really just means the area under the curve from a to b. Okay? So all this is doing is saying that what we did last section can be written as an integral. That's what it stands for. Remember that this part of the limit statement is a Riemann sum, just so when we hear that used, we know what we're talking about. Okay, so f of x is a continuous function in order for this to be true. Delta x, the width of the rectangles, is b minus a over n, and x sub I, each x value is a plus I delta x. Okay, and then we remember from last section, if I'm using right or left, the different notation. Okay, the integral sign is that, like I said. Okay, the integrand is what I'm actually taking the integral of. The limits of integration are a and b. Those are just the numbers. Okay, the lower limit and upper limit, that's a and b. And integration is what we're doing. Just like differentiation, now we're doing integration. The definite integral is a number. So what that stands for is like 5 or 7 or 2.3. That is the area under the curve. Okay, and remember, we talk about area under the curve, we're talking net area. Okay, total positive area. So it's what's above the curve minus what's below the curve. Okay, so now number 1, the integral from 0 to 3 of x cubed minus 6x dx. dx is just saying that I'm in terms of x. This really doesn't do anything. It's notation. Okay. What does this mean? This is actually standing for the area under this curve from 0 to 3. Okay. And all we want to do here is write it as a limit of sums from last section. So this is just understanding that this is the same thing as we did last section, where what? My delta x would be 3 minus 0 over n, 3 over n. Okay. And if I do right endpoints first, your x sub I would be 0 plus delta x, 3 over ni. Okay, and then how do I write that? The right would be, the limit as n goes to infinity of the sum from 1 to n of what? Remember, it's just going to be f of x sub I times delta x. This is your height, this is your width. So f of x sub I would be, I would plug in 3 over ni for x. So it would be 3 over ni cubed minus 6 times 3 over ni. That's f of x sub I times delta x. So this integral is this limit statement. They're the same exact thing. What do they stand for? They stand for the area under that curve from 0 to 3. I'm not actually finding it yet. Okay. Using left, what's the only difference now? X sub I is going to be 0 plus 3 over n times I minus 1. Got to go back 1 in order to get left endpoint. So it would be the same thing. Limit as n goes to infinity of 1 to n. Now instead of 3 over ni, I'm plugging in 3 over n times I minus 1. Cubed minus 6, 3 over n times I minus 1 times 3 over n. Okay, so there's my right, there's my left. So I'm writing the integral as a limit of sums using right and left. Same thing. You could try the next one. Okay? You can stop this, try this. So what would delta x be? Delta x would be 3 minus 1 over n. Again, 2 over n. What would x sub I be for right? For right, it would be a, now which is 1, not 0, plus delta x I. Okay? And then what are you going to do? For right, it's going to be the limit as n goes to infinity, the sum of 1 to n. That just means as I make my rectangles smaller and smaller and smaller and smaller. Of what? E to the x. So it would be e to the x sub I, which is 1 plus 2 over ni, okay, times delta x. This integral is the same as this limit, and it is the area under that curve from 1 to 3. Left, x sub I would be 1 plus 2 over n I minus 1. Same thing over here. The sum of 1 to n of e now to what? The 1 plus 2 over n I minus 1 times 2 over n. Hopefully this part's review, it's just understanding that this integral, this definite integral, why is it called definite? Because I have values I'm starting and stopping. Okay? This definite integral is just the area under the curve. Okay? Okay. So now I have evaluate each by interpreting each in terms of areas. So this is just saying, what does that really mean? The integral from 0 to 1 of that really means what? Means the area under the curve. Now, not sure we recognize what y equals the square root of 1 minus x squared is. Okay, it's actually a circle. How the heck would you ever know that? If you square both sides and then add the x squared, I get x squared plus y squared equals 1, which you would hopefully recognize that as a circle. X squared plus y squared equals 1 with a radius of 1. So this is really just that, because it would be the entire circle, but I'm trying to just find the area from 0 to 1 under that. So not knowing how to do integrals, how to do definite integrals, we can find this just by saying what's the area of a quarter of the circle. Okay, the area of the entire circle is what? Pi r squared, and I just want a quarter of it. So my answer would be pi over 4. So this area is pi over 4, just by knowing the area of the entire circle and taking a quarter of it. Okay, next one. We know that x minus 1 is just a line. So go ahead and graph it. Okay, there it is. And I want the area from 0 to 3. So I want this total area. Okay? So now we have to remember, it's going to be this, the area above the x-axis minus the area below the x-axis would be the answer to this, because it's net area. Okay, how are you going to find that? Well, these are just triangles, 1/2 base times height. So the little one that's below is 1 by 1. So it would be 1/2, 1 times 1, okay, which is just 1/2. That's going to be negative because it's below. I'm adding the area above, okay, which is what? 1/2. The base is 2. The height is 2. So 2 times 2, okay, which is what? 2. So my final answer is 1.5. So the area, so basically this area right here is 1.5. Again, the whole point to this is recognizing that integral means area under the curve, under this curve from 0 to 3. That's what it means. Right now we're finding it just by graphing. Eventually we're going to find it algebraically. We're going to be able to say, all right, how do I find that algebraically without creating a graph? Okay. Next I have the midpoint rule, which is really we're done. Okay, it's saying the sum, an integral from a to b of f of x can be estimated by the sum when I is 1 to n of f of x bar I1. This is just saying using midpoints, basically. This is just saying midpoints. Instead of left or right, use midpoints. We've done this. Okay, so use the midpoint rule with n equals 5 to approximate that. Sometimes it's easier to get a picture what's happening. So hopefully we know 1 over x looks like that, two curves, but I just care about from 1 to 2. So 1 to 2. So I want, this problem is asking for that area under the curve right here, this total area. Okay? Now it's saying with n equals 5. So how do you find the width of the rectangle? Delta x would be what? b minus a over 5, which is 1/5. So that means over here I'd have 1.2, 1.4, 1.6, and 1.8. Those would be my rectangles. Now, if I'm using midpoints, what are the actual midpoints of your rectangles? Okay, so here's delta x, the width. The midpoint would be 1.1. So 1.1, 1.3, 1.5, 1.7, and 1.9. Those would actually be the x values of the heights of the rectangle that I'm using. Okay, if I come over here and draw them, so that's the actual rectangle. If I'm using midpoints, guys, some of the rectangle will be above and some will be below. Those are the actual points on the curve you're using, the midpoint of the rectangles. And you're just finding the area of those 5 rectangles and adding it together. Okay, so how do I go ahead and do that now? Oh, let me change back to black. So how do I do that? So the integral from 1 to 2 of 1 over x dx, okay, can be found by doing what? F of 1.1 times delta x plus f of 1.3 times delta x plus f of 1.5. This is just length times width of each rectangle. 1.7 delta x plus f of 1.9 delta x. Now plug your numbers in. What's f of 1.1? So plug 1.1 into the function. So it would be 1 over 1.1 times delta x, which is 1/5. That's the area of this first rectangle right there. Next one, plus 1 over 1.3 times 1/5. It's the area of the next rectangle, right here, this guy. So on and so forth. F of 1.5 times 1/5 plus 1 over 1.7 times 1/5 plus 1 over 1.9 times 1/5. And if you actually do that out, you get 0.6919. So that's the estimated area using 5 rectangles. If we use 10, if we use 20, it would get closer and closer to the actual area. Okay. All right. And then in the last page, there's not much to do. This is just stating the properties. The most important one here is the first one. We're going to use the most. The integral from b to a, so of f of x, is equal to the negative integral from a to b. So if I say find the integral from 5 to 2, where the bottom number is bigger than the top number, of f of x dx, that's going to be equal to negative from 2 to 5 of f of x dx. That's all we're saying. Okay? That's all that we're talking about. If I go from 5 to 2, it's just going to be the negative value from 2 to 5. Okay? Why? Because if you go from 5 to 2, all of your delta x's would be negative. So if I just take that negative out, I could switch them and now do it regularly. If I go from a to a, obviously I get 0. If I'm going from 2 to 2 or 3 to 3, it's always going to be 0. Okay? If I'm just finding the integral of a constant, that's important too. Number 1 is saying, if I just want that, the integral from 2 to 5 of 5, what is that really saying, guys? That's saying find the area under the horizontal line 5 from 2 to 5. It's just going to be a rectangle. This is just saying you have a rectangle. How do you find the area of the rectangle? Well, it's just that C, okay, this value, which is, this value, C, times the difference between these two, just length times width. Okay, and then the other ones are just saying, just like before with derivatives, if I have an integral of f of x plus, I can separate them, do it separately. Okay, if I have a constant, I can take out in front subtraction, I can separate it. This is another important one. If I'm going from A to C and C to B, that's going to be the same thing, just going from A to B. So if I'm going 1 to 2 and 2 to 3, it's the same thing as going 1 to 3. Okay, I'm going to skip this right now and then just look at the other properties that are more important when we actually use them. Okay, but if the function is positive, then the area under the curve has to be what? Positive. Pretty simple. If I have some function that's above another function greater than another one, and guess what? Its area is going to be more than the area of the other one. Hopefully this all makes sense. You have two graphs. F is up here and G is down here. And you find the area under the curve. This area is going to be greater than the area under that curve. Okay? And then next one, if m, little m is less, if f is in between little m and m for some value, okay, then this is just really saying I have two horizontal lines. Okay, and if this is like 2 and this is 5, the area under 2 is going to be what? Less than or equal to f of x will be in between those two. So if this is little m and this is big M, here's big M and here's little m, and I have a function in between them, the area under the function in between them is going to be in between the area under that line and the area under that line. Pretty simple. This you're not going to use that much. Okay, these are just obvious. The ones that we're really going to use are the ones above. Okay, general idea of this section is just introducing the notation of a definite integral and what it means. So a definite integral is just the area under the curve from A to B.